That was really nice. Elevator music. Okay. Sorry, we have no elevator music handy here. So, you actually got to enjoy the easy part. You got to multiply. Division creates a little more issue for us on a couple things. Although the rule should be fairly obvious, I'll ask. What do you suppose you do if you have x to the 6th divided by?
X to the second.
Ooh, and why did you? And it makes sense if you, when you multiply, you add. You would think when you divide, you should subtract, and you would be correct. So yes, that is indeed x to the 2nd. So your rule says a to the m over a to the m becomes what? Yes, m minus m. It's top minus the bottom. Top exponent minus bottom exponent. That's your... And, you know, if it's something that's set up nice, that's all fine, good, and well. It works pretty... Okay, so I'm going to have to guess you all can do this one with a little effort.
Hang on.
What do I do with the coefficients of 12 and 4?
Second, g to the third.
Okay, Stephen whipped that one right out there. We got 12 divided by 4 is 3.
Write it down. Oh, Miss Meyer, you can use for that. He didn't agree that you could use name.
Oh, I'm sorry.
I actually have the thing signed where you can use my name.
Okay, thanks.
No worries.
And yeah, we just subtract them, it's no big deal. But a burning question should be coming to your mind. What if well, what if this happens? What if I give you b to the 2nd over b to the 7th and the larger power is on the bottom?
It's on the bottom. No, it's negative.
Well, actually, you just gave me both correct answers, because ours too.
I said both.
No. That is not the case. It's going to happen. So, b squared over b to the 7th, you can subtract your two powers, and yes, it would be negative 5. You can have negative exponents. Most of the time, we don't want to have negative exponents. We try to avoid them. Okay, the other one, which I don't know that you actually realized you were saying it, but somebody said it'll be b to the 5th on the bottom.
That's what I said.
That's right. Why?
Because if... I don't know.
Well, where's the larger power? The larger power is on the bottom, so you can actually, yes, you can subtract them and say, oh, okay, b to the 5th can also be on the bottom. So you actually just discovered rule number 4.
So if it's on the bottom, you don't have to say it's negative?
No. If it's on the bottom, it stays positive. So what you've just found is rule number 4. It doesn't get you that well. You have to speak pretty loud and clear for it to pick it up. It'll hear your noise. Okay, so a to the negative m. What can I do? If I don't want a negative power, this is saying... There we go. 1 over a to the m. I can simply drop it to the bottom. So if you have a negative exponent, you can move it to the denominator and make it positive.
Cool.
Very handy rule. Incredibly useful. That is the rule right there, yes. No cherries for that one. We're actually going to put this one to use quite a bit. So if I do g to the negative 8, what's another way to write that? Don't swing your pedometer.
Swing your pedometer.
1 over g to the 8. Okay, we all do the variables fine. I throw this one at people, and I will get a million wrong answers.
1 over 2 to the 1 over 2 to the 3. No.
Yes, I will buy 1 over 2 to the 3rd. I always have people tell me it's negative 8.
They don't. Well, they're multiplying by...
Well, what's 2 cubed? The real answer is it's 1/8. But they see that negative power and think they can just throw the negative out front and change the whole thing to a negative value. That does not work that way.
I wish it was that easy.
Yeah. We may wish it's that easy, but it's not that easy. Guys, you're noisier than usual.
I blame the pressure. We're ready for it. I blame Ken. I blame Ken.
Okay, I'm about to get trickier
We
here.
appreciate you, Miss Meyer.
Uh-huh.
Thank you.
Thanks. I'll be so ever glad that I read that segment of that. I get more thank yous now.
That's what you wanted, right?
Yeah, if they're sincere.
Wait, you have a thank you. You were the one that said that you don't ever get thank you?
I was the one who read that part, yeah.
Yeah, she was right before Steve saying I want to sing.
So, simplify this one for me. It's got base numbers that are bases that are numbers. Because you could do it 2 ways. I would prefer you went, oh yeah, subtracting the bigger numbers on the bottom. Let's leave the 2 down there, which actually 1/6 squared is what?
36.
136. Yeah. You could have an alternate option. You could have done 6 to the -2, but then you would have had to turn around and drop the negative exponent right back to the bottom again. Okay, but now I'm about to make this all simple. This is crucial. Actually, not to rule number 5 yet. This is a how to make this whole thing with the negative exponents very simple. I want to simplify that whole expression. Okay. You do each base as one term. So we have to simplify the A's, simplify the B's. Where you move the A's is not maybe where you're going to move the B's. Okay, you want A to the 6 on the bottom, why?
Because it's negative.
Okay, and I want you to realize, to get -6 on the bottom, all we're doing is we're saying, oh, I'm going to take the A cubed from the top, I'm going to bring to the bottom, which means I have to subtract 3. All I did is I took the 3 that I had there and I changed its sign. So now I have, no, it's saving, it's okay. So I have A to the 6 on the bottom. I took the 3rd power up here and I moved it to the bottom, it became -3. So what can I do with these B's? I got a -4 on top and a +2 on the bottom. Yeah. If you move the B, the -4 down, it will become +4. So yes, you're just simply going to take that B out. You're going to say, I'm moving it down, so it's going to change signs again, and you're going to add 4 to the bottom, which is going to give you B to the... Okay, so C. I want them to come out positive. So which one should I move? If all that's going to happen is it's going to change its positive or negative sign.
C to the 3rd on top.
Yeah, I would bring the 5 up, make it a +5 then, and you'll have a C cubed. And then last but not least, the D's. Where would you like to take the D's?
On top.
If I bring -3 up, it'll become +3, and I will have D to the 11th. It's technically because it's a minus and negative, but in reality what's happening is all you're doing is changing signs. When you move from top to bottom, all you have to do is change the sign on your exponent. That's all it takes. Unfortunately, no textbook ever explains it that way. They will teach this as you should have done -2 minus a -5. And -2 minus a -5 for the C's would make a +3. They'll teach it using those rules, not make it simple with it. It's simply a matter of if you move from top to bottom, you change the positive or negative sign on the exponent. All you have to know. Explains it all. But you won't find that explanation in a textbook. So hopefully that makes it easier to do something like that. Okay. Okay, rule number 5. This one caused the greatest debate this morning.
Yay. I like debate.
You like debate?
We do it. Not no more. We ever? Yeah. We did.
Okay, the last rule for today, at least on this section, is what is anything to the 0 power?
Zero.
I got zeros. Anybody else want to argue?
One.
I got a 1. No, you're not going to cheat and put your calculator.
It's times itself.
I got zeros, I got 1s. That's the usual debate. Okay, would you all agree that if I gave you x to the 5th over x to the 5th, if I subtract those exponents, shouldn't I get x to the 0?
Yes.
And what is anything divided by itself? 1. So therefore, anything to the 0 power is always 1.
Amen.
You put a 0 power in? You put a,
That's not helpful.
or did you put a variable to a 0 power?
She doesn't know what.
What did you put in?
Redo it.
It should say 1. If you haven't defined the variable to have a value, it doesn't matter. So, okay. So it should always be 1, regardless of what you got there. It's always 1. Okay. So now I'm going to show you a couple, like that one thing here with the negative exponents and the fractions, and then I'm going to give you the big ultimate practice problem.
Yay.
Before we do a touch of scientific notation. But before the ultimate exponent problem, let me ask you this one. If I gave you x cubed over 2y to the negative 4th power, when you have a fraction with a negative power on it, there are 2 ways you can work it. They're both legal. They're both fine. One is quicker. Yeah, they're both legal.
Which one's illegal?
What are you all inclined to do with that negative 4 power on the outside? Distribute it. Do I have to distribute to top and bottom?
Yeah.
Yes, I would.
Yeah.
Okay, so if I did that, I would have x to the negative 12, 2 to the what? Negative 4, and y to the negative 4. Well, they're all negative. What would I end up doing? To make them positive, where would I have to move them? They'd have to, yeah, x to the 12th would have to come down to the 4th, which is actually 16, and y to the 4th would have to come up. So, in reality, all you ended up doing is you caused them to switch places. So, what I recommend, the quicker way, if you have a fraction with a negative power on it, that negative is going to make every term flip over. So if it was me, I wouldn't do it that way. That's legal. I would go, hey, I'm just going to switch this thing around, put the 2y on top, the x cubed on the bottom, and put a positive 4 power on it. Then I don't have to mess with all the negative powers. People tend to lose negatives and mess up negatives. Because now, all I have to do is 2 to the 4th, y to the 4th, x to the 12th, and I have my 16, y to the 4th, x to the 12th. So if you have a negative power on a fraction, flip the fraction, change the power. Okay, we're going to pause again before the ultimate exponent problem. Get psyched.